Thank you for joining us to watch and learn about a cool project that Oscar and I have been working on called SmogCloud. And what we wanted to talk about was how to identify whether or not you can find and collect all of your exposures in your cloud environments. Really, anyone that is here to learn about this, the type of folks that may be most interested in this would be if you're in a blue team that is responsible for monitoring and securing like AWS infrastructure, or if you are a security engineer that's looking to implement automation for improving continuous monitoring and continuous security analysis, or if you are an internal pen tester or internal red team member or a consultant that has access to a lot of these environments and wants to be able to perform more comprehensive analysis. We really were setting out to answer the question and the goal of how do you determine what is exposed in these environments at any given point in time, and to be able to instrument that type of information for further automation. Really what our success criteria for building up this type of inventory of assets was, we wanted to make sure we had as comprehensive as possible of a list of exposed services. Wanted to be able to frequently update it and keep it accurate, and by frequency I mean as often as like on a daily basis. As we set out for some of the target environments we were looking to prototype this on, these were like large multinational organizations that had hundreds of different AWS accounts and had thousands of developers that had adopted very agile continuous integration, continuous development type of methodologies. And you could expect pretty significant amounts, orders of like dozens or hundreds of changes to these environments in a single day. And to be able to stay on top of that and know if there were exposures, even if they're ephemeral in nature and only exist for a short window of time, wanted to help facilitate automation that could give us visibility into what those exposures are, help us get screenshots on them, other fingerprint and metadata about them, and really determine if it was an impactful exposure or not, and to have a better idea if an attacker would be able to identify it and exploit it, and put that in front of our team to be able to investigate, all on a daily basis. And so to get into what we did as we were researching this and what we did as a first pass of a solution, we came up with this tool, SmogCloud. I'm just gonna already have it set up and running here. Gonna run this on an account that we had for another research project that just has a few different core services of AWS. You can see it's output in JSON format, but just while that's running, I'm gonna go over and start to show you some of the results. It is essentially doing a enumeration of every possible region into AWS accounts, and it's doing a enumeration of each service that has the opportunity to expose something externally, and just recording the output of that to EC2. Oscar, do you want to kind of elaborate a little bit more on how it's designed and architected to query this information?
Sure. So whenever you create or spin up a service within any cloud environment, and within AWS, there are sometimes host names that are associated with those services that can be publicly exposed. And sometimes that's a configuration change. Sometimes that is just by default. And essentially what that ends up doing is adding to this attack exposure from your external environment. As an example, if you create an Elasticsearch, spin up an Elasticsearch instance within AWS, and you provide it with your user provided name for that specific service, you will receive a host name that is kind of your user provided ID plus a randomly generated ID provided by Amazon, then the region, and then es.amazonaws.com. And so that specific pattern will show up for these Elasticsearch resources that you externally expose. And a developer may create that thinking that it's only accessible within their VPC, and maybe it's exposed to the internet. Maybe it's a public facing instance. So the idea behind this is, can we query for that information and extract that from your AWS accounts in order to be able to test from an external perspective if they are externally accessible and if they may be misconfigured with security issues.
Yeah, so this tool is going to be available for you to download through GitHub. There's an opportunity. It's a Golang application. You can pull it right from this Git repo and compile it. Has the option to set it up to use environment variables for keys. And then, just as I demonstrated, you can just run SmogCloud from the command line, and it'll go fetch these keys and then query your environment. This is a quick rundown of the native services that it will search to extract information. And as Oscar mentioned, like, we documented out the patterns that you should and can look for with SmogCloud. This would be like if you are looking to improve your monitoring of potential exposures in your SOC or in your current whatever solution you're using to monitor configuration of cloud security. This can give you a better idea of some exposures that may occur if developers are using these native services and what the paths are to interact with them. We'll show you a few examples of like what those would look like kind of in a real world environment. Before we get to that though, like Oscar, do you want to speak to kind of how we were able to research what these patterns look like? Oscar?
Yep. Sorry, mute. When we first started this research, we found a handful of GitHub repos that seemed to be updated fairly frequently and contained some of these access patterns, this host names that we've targeted as part of this project. Since then, we've started looking at the AWS CLI as one of the resources of how to go about finding which services out of the hundreds of services that AWS provides will actually create an externally facing host name or an externally facing IP address that could be accessed from the public internet. And so in some of the files within the GitHub repo, we've listed out all the endpoints that we've identified as exposing either an Amazon AWS.com host name or Elastic Beanstalk or a handful of other targeted domains, and gone through the process of reviewing those for where which services would expose those externally. So we've gone through 14 of them, and we've kind of done the translation of what those 14 may look like. And we're kind of looking to continue that process for the rest of the services that were identified as having potential for externally facing services.
Yeah, you can see here in the code base, really what the main function is doing is it's going to the Golang AWS SDK and allowing us to kind of instrument interacting with each of the objects that represent these services. Some of them are global in configuration, such as like CloudFront, Route 53, and S3. So that meaning like these will be globally available across your AWS account. Some are specific to regions. So we actually have to enumerate each region and then check if in that region a service like Elastic Beanstalk is being used, or there's native instances of Elasticsearch being used, and or like RDS databases, for instance, and see and pull out in that region all instances that the engineering group may be utilizing to get the specific entry and pattern to interact with them from an internet like reachability perspective. Each of these services has like specific API endpoints. There's not really consistency between these in the SDK, so it kind of appears to be like left up to each of the development teams at AWS. But we've captured and done the research based on the documentation and based on what was available of how to pull out like the domain descriptions or the patterns of like what it would take to interact with like an Elasticsearch instance in this case. And be able to 100% confirm if it is internet reachable. Oh, sorry, go ahead.
No, I was going to add, essentially, we try to extract 3 different pieces of information from these services. One of them is host names that may be externally resolvable. The other one is like URLs or URIs that may be externally accessible, or IP addresses, which are externally facing that are associated with your organization or your account.
Yeah, and a good example of like where just maybe an IP address that's exposed would be like this EC2 instance. Like we have to query if there's like a DNS name or an IP address name, because you can have either or. So there was some tailoring to kind of get this to work for specific services and get like the most comprehensive information available. What this ends up looking like when it's a real exposure, we're able to mine some passive DNS data sources that we have access to then query for these types of patterns, like looking for everything in US East 1 that is a native Elasticsearch instance, and then getting a list of all of those possible records, then seeing if they are actually accessible over HTTPS, and then subsequently like looking for a common vulnerability that leads to a lot of data breaches and sensitive information leaks is requesting this path, this _cat/indices?v, which is verbose indices being listed out. And then we were actually able to find and this is kind of just current point, this changes up and down and based on the information that's available. We did confirm 596 exposed instances of Elasticsearch, and thousands of these contain like multiple megabytes of specific indices that you could download the data from. Some of them are benign, some of them are generic, but sometimes it does contain sensitive information like PII or credentials or something that's specific to the application it's supporting, or logs that may contain other sensitive info. But when you read about like an Elasticsearch breach in the news, it may have been of something like these instances that we're able to uncover from looking at these patterns in AWS. One interesting observation that we actually had was for the native instances, you actually needed to query it by its fully qualified domain name. If you query by IP address, you actually get a user is not authorized to perform this action. And this is really interesting because this kind of breaks a fundamental assumption that our IPv4 vulnerability scanners are sufficient to find this type of problem, but just based on the nature of how AWS is ephemeral in its IP space usage, and it's dynamic, and it's kind of reserves the right to swap those around as it needs to, you actually need to focus more on the fully qualified domain names as a means to tell if there's an exposure there, which also kind of aligns with why we wanted to build this capability to query all of that information that's available. As we dug into some of these other native services, it was really interesting to kind of see what other exposures we could find. One of the native services is called Media Store. We actually found that this is designed to stream and be like a CDN for video content. We actually found Samsung TV Plus channels that were exposed, and did a little bit more research into this, and these appear to just come with anyone that owns a Samsung TV. There's a built-in app into that smart TV that allows you to stream these channels, but we actually found them unauthenticated, and showed that we could just launch a VLC instance and hit the playlist endpoint to start watching these TV channels without any type of verification that it was coming from a Samsung device or any type of authentication. And that was another interesting observation. This kind of fits into like an overall methodology that we had of how we wanted to map out the attack surface of an organization. We've been really looking for more holistic approaches, especially for large and complex organizations. We found that starting with a high level of what the brand is, first and foremost, can help us paint a better holistic picture. Really defining what that organizational structure is. And by that, I mean, what is, in the same way that like your HR or your internal reporting may have an org chart that is used to, from a management perspective, we've really tried to mirror that in painting a picture of how the organization's asset inventory should be built. Because there may be different business units, there may be different engineering teams, different IT teams, there may be different groups that have come in from mergers and acquisitions, and each of those business units may have their own products, may have their own services that all have their own IT infrastructure, and how that translates into how customers and employees interact with it is typically going to be through domain names and fully qualified DNS entries, or through IP address space, and really being able to identify that comprehensively and blend that together has been the best way for us to build that more comprehensive map. And our ultimate goal then is to really be able to identify active services in the forms of like open ports that we can interact with to build like targetable set of data that we can operationalize into seeing if it has any vulnerabilities or has any exposures. Really, the other final step of this that becomes a challenge is continuously maintaining this and continuously keeping it up to date on as frequently as a daily basis if possible, so that you're always working with the most active data set. This tends to span out into like quite the broad tree if you're looking at it from this very comprehensive perspective, to a broad list of domains that could be associated with business units, their subdomains, their IP space, and their services, and blending all of that together. We really found that you can take this pretty far with open source intelligence gathering, and you can take this like pulling from internet data, from like Whois archives, from internet scan information, from passive DNS, looking at certificate transparency logs, looking at things like reverse DNS, forward DNS, BGP prefix information that's published in the ASN. You get a pretty comprehensive list of what is exposed, but there still is a good chance that you're missing things. So we wanted to build a way to tap into the master records that are available, and that's really where we felt like this SmogCloud tool was a good basis for research and development into us being able to get tapped into the metadata endpoint of an AWS environment, and tap into that SDK to really get the full picture of blending that with what we discover from the outside. This would include like the Route 53 information can help give us information about what domains are being registered and maintained, what the changes to those DNS records are, and then also help us confirm what native services are being used and what ports and they may have exposed that we can interact with.
Yeah, from the perspective of trying to monitor your own attack surface, if you're looking at your registered domains and the subdomains associated with those registered domains, there may be instances where a developer has launched infrastructure within AWS and hasn't tied a domain or a subdomain to it, which makes it very difficult for someone to directly attack in terms of them attacking your organization as their main goal. But since these are things that get exposed externally, opportunistic attackers can often review that data and find those exposures and still compromise your organization, even though, and then essentially tie it back to your organization after the fact. So those, for example, those Elasticsearch examples with those domains, it's very difficult to find those and associate those with a specific organization, but the data stored within those indices may tie it back to your organization if someone's opportunistically attacking and then trying to just identify those exposures.
Yeah, so in an effort to stay ahead of these opportunistic attackers that are scanning the internet, exploiting anything that's available or anything that's vulnerable, and then later figuring out who it belongs to, or how they can maybe extort the owner or just steal that data and leverage it to sell, we found like taking this approach of not only using the same techniques that they're doing, which is scanning the entire internet and correlating it back to an organization, but also tapping into the master records where possible, was helping us build the most comprehensive map and inventories of organizations' attack surface that really anyone had seen. And there was really benefits to taking this two-pronged approach. When we were looking from the outside and kind of simulating what real attackers do, that was also helping us find shadow IT whenever we were comparing it to master records. Like tapping into like these master records should be your source of truth, but if you're seeing things that you can confidently attribute to the organization, those may be in that may be an opportunity to improve your own inventory of where are all of the accounts, where are all of the master records that you need to have the security team get visibility into, or it just may be a case where shadow IT has been identified, it needs to be removed or shut down. But this, like, combining both of these techniques really was helping us stay a step ahead of attackers, and building a much more thorough map of what's exposed. Comparing these, actually, in some cases, is like an example of like just a Venn diagram of one large multinational organization that we applied this technique to. When we compared to what they knew about themselves, we actually had found like over 3,100 new domains that they weren't tracking. We were able to put like them in different confidence categories based on how many attributes of confidence. Like, did it have a whois record that we could associate to an email that we knew belonged to them? Did it have any organizational name or other info on the whois information? Did it have any details about a known domain in the certificate that was used for a web app on that subdomain? Did it have any, like, was from a reverse DNS perspective, was it using a server that we know belongs to the organization? And then also ultimately we're using screenshots as well as like a fourth indicator of, does it have the company branding on it, or is there something visually about it that we can categorize it as belonging to them? And this was helping us find like significantly more domains than an organization knew about. And once we like started exploring the path of going into the master records, some other techniques that we found really advantageous were to actually get the security team and the finance team talking to one another. So maybe it's a matter of the CISO going to the CFO and saying, we'd really like to tap into some of the corporate credit card and finance billing information to find all credit cards that have AWS charges on them, or that have other like cloud environments charged to them. And in a lot of cases, this was helping security teams we were working with find significantly more accounts than they were currently monitoring. They may have been monitoring like the primary production accounts or the primary like main accounts, but in many cases found like dozens of other accounts that had been set up for dev purposes or staging environments, or some experimental project, or some project that was sponsored by another group in IT that hadn't really like going through channels to make sure that security even knew about it. But this was giving them a way to track those down and start getting tapped into that information and feeding it into the centralized security monitoring dashboards and places to get alerting whenever there's changes made. One thing to be aware of this technique, though, is this won't help you catch like other third-party services for infrastructure or platforms as a service that may be using cloud environments in the back end, but may just not show up as that in the credit card. So it may take more refined classification of the billing to really get a comprehensive view of this. But in really all cases where we've seen this technique applied, it's helped the security team increase their visibility. Really what you want to do as a next step then is the security team should also have an account. This account would really be used to set up a assume access role into all of the other accounts that are identified. Oscar, do you want to speak a little bit how we've done this for some large organizations that have hundreds of accounts?
Yeah, so essentially the way that it works is as the organization, for each one of the accounts that you have, you create a new role that enables a specific account to assume all of its permissions. And so we have one account that is associated with one organization's, all of the organization's accounts, and we're able to essentially get a like temporary set of keys associated with each one of those accounts to pull this data out and add it to the asset inventory.
Yeah, and so once you have that account access established, like really your criteria should then be, we're trying to extract like what are the public facing systems and services, and how are they externally accessible? Is it by a fully qualified domain name? Is it by an IP? Is there a port associated with it in the config? There's other levels of access that we're not really covering with SmogCloud and in our use case, but you just wanted to make sure you're aware of them. There's the concept of like internal access, like is this actually exposed to like regional offices that have routing to these AWS environments? Are there interoperability between AWS accounts that are separate logically but have joint network access, and there may be exposures to explore there? There's some built-in AWS tools like IAM Access Analyzer that can help answer those questions, but we were really focused on the internet level of access for the questions we were trying to answer. And we wanted to be able to build a comprehensive list of like the scheme and protocol, or the host, whether that's DNS or IP, the port, any other relative URI path information, like you saw, like the request of like the playlist in the media store, and try to get definitions of that to see if there's any anonymous internet access that's available that we can then run through further analysis to try to find unnecessary exposures or unnecessary vulnerabilities. And we really wanted to be able to do this at the scale of collecting everything and then seeing what was vHosted, or seeing what could be pared down to a more like narrow list of something we want to track on a continuous basis.
Yeah, it's important to note that the specific internet scanners can't find these types of exposures on these types of cloud infrastructure in a lot of cases because they are vHosted. So unless the scanners are running with the correct host name, you won't expose those specific vulnerabilities.
Yeah, as we started to look at answering this question, we found these 4 different tools that also seem to try to answer that question of what's exposing it. These tools do a lot of other things in most cases, and may have like a bit of a significant more setup overhead. But a lot of them even kind of in their documentation said, we're not really giving you a comprehensive list of everything that's exposed. We're maybe just focused on EC2 and Route 53 and a few of the core like services. They didn't really help you like check if every region was using these services. You kind of had to know a lot of the answers to those questions ahead of time to know, like you basically had to write a query of what you wanted to look for. And so this is what led us down the path of making a tool that would allow us to do this on our own, and really wanted to spend the time to research what are those patterns of what can those exposures look like, and then can we work our way back from that and write a tool that does this one thing well, of go export all of these native services if they're being used in every region, to give us a comprehensive list in each AWS account that we have access to for an organization, and then set that up for additional scanning and testing. And so yeah, we're really looking for anyone that's interested in utilizing this for your feedback, looking for contributions. If you have any issues or bugs with it, welcome you to report them, and really seeing and excited to see how the security community can utilize this and extend its capabilities. There's actually quite a bit more work to do if you're interested in contributing, and there's always new services coming out from AWS. Oscar, do you want to speak a little bit to how we're tracking these and like how we kind of see what work's cut out for the future of maintaining the tool?
Sure. So in the GitHub repo, we have a file called the AWS services service endpoints, and essentially it is all the instances that we identify that look like they exposed an Amazon AWS.com, elasticbeanstalk.com, or CloudFront.com or CloudFront.net endpoint. So we've gone through the process of crossing out the ones that we kind of reviewed more closely and have a set of checkboxes for the ones that we've implemented already. So there's a lot left to review and kind of go through that process of identifying what are the endpoints, which ones are the ones that actually expose publicly facing systems, and then for those, are there associated host names, ports, schemes, or like relative URIs that are important to be able to access those endpoints.
Yeah, so it's important to note, like while there's thousands of API endpoints in total in AWS, and there's like hundreds of different native services, not all of them can or will create externally internet-facing exposures, but quite a few do have that ability, and we were kind of really going through looking at the candidates that do, and if it's not really consistent, like we said, but there's seems to be patterns like where there's describe or get in the API path, and it's a service that is creating infrastructure. There's a good chance that that is a good candidate to add to the tool and to be able to extract the information.
Yeah, so we've gone through and we've added 14 of the ones that we identified to the tool. There's many more to review and add, but yeah, definitely looking for any contributions of anybody else that's interested in going through those endpoints.
Yeah, I'd say in total, like we've already reviewed the 288 endpoints. There's 62 services that actually can return hostname, URI, or IP information. So those are really the candidates to go have like an additional class added to this to pull the information. Yeah, and wanted to also just reference a couple things that we found useful while researching this, of like how to run commands across all accounts in all regions. Like this is, I think, something that's kind of quintessential to making sure you do this in a comprehensive way. So there is an element of like we're basically having to brute force every region to see if these services are used by engineers, and to answer that question, like, are there exposures? So I'd say that's something that's kind of unique to this tool that can be applied from a security perspective to really just make sure you're getting as comprehensive coverage as possible. And with that, thank you for listening, and we're interested in any questions you may have. Feel free to reach out at the email here, or look forward to hearing what else you'd like to learn in the live Q&A at Black Hat Arsenal. Thank you.